So here we have, so n equals to 128k plus 28, right? So then the length of n is equals to length of n plus 1 equals to length of n plus 2. So this you have to prove, right? So previously we shown that for 8k plus 4 it is same as n and n plus 1, right? The both of the length are same, right? So we have to apply that 3n plus 1 algorithm, right? So let us see what happens. So suppose I am starting with n. So 128k plus 28. So it is even, right? So what will be the next step?
I mean, you can do n plus 1.
Yes, no. So for n, we are applying the 3n plus 1 algorithm. So it is even, right? So it will get divided by 2. So if you remember the algorithm, so this is
Divided by
right?
2 or 3. If it is even, you divide by 2. If it is
Right.
odd, 3n plus 1.
Right. So here, then
So
what will be the next step?
that is even. That would be 64k plus 24.
14.
Same thing would be even 32k plus 7.
Right. Now it is odd.
That would be odd.
So 3n plus 1.
That would be 97. No, 96.
96k. Right. Plus 22. Right.
Yeah.
So now it is even. So it is 48k.
48k plus 11.
Right. Next.
144k
Right.
plus 23.
No. 3n plus 1, right? So 34.
34.
Right. So next one is 72k.
72k plus 17.
Right.
216.
Plus 52.
62. 108k plus 26.
Then you have 54k
plus 13. 162. 40.
40. Okay. So let us stop here and then check for n plus 1. So n plus 1 is nothing but 128k plus 29, right?
Plus 29.
So it is odd. So it will be 3n plus 1. So 384, right?
384.
Plus 88. Then it is even. So
That would be
190.
192k plus 44.
Yes. So 96k.
96k plus 22. 48k plus 11.
Yes.
Yeah, so there's 148k above.
48k. Yes. But the thing is, yes, that you have to check. So, but for n plus 2 also you have to check whether 48k is coming or not. Okay. So let us do some more steps and then we'll get an idea. Okay. So 48k, after that it will be same, right?
Yeah.
Okay. Let us check for n plus 2. So what is happening? So n plus 2 will be 128
plus
plus
30.
Right.
Will be 64 plus 15.
Yes, 64. Right then.
192 plus 46.
Okay.
96 plus 23.
Right. So here actually 48 plus 11 will not come, right? Because it is 96 plus 22 and here it is 96 plus 23, right? So it will go somewhere. Okay, let us see. So 288k plus 70. Then
144k plus 35. 432.
Right.
K.
432k plus 106.
106. 216k plus 53. That would be 648. 150. 160. 180. 178 or 172. Yeah, 162.
Right. So yes, now it is matching, right? So here I have 162 plus 40. Here also 162 by 40, and here also, since it is repeating, so this remaining part will also come, right? So now the number of steps, let us count. So here we have this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 step we are getting. Here also 1, 2, 3, 6, 7, 8, 9, 10. So length of them will be same, because after, since all of them are reaching this one in 10 steps, right? So
also
the
n plus 1.
Yes, n plus 1 also same thing, right?
Yeah.
Right. So what is happening is, so after 10 steps, n plus 1 and n plus 2 all are reaching to the same quantity, right? So after this, since it is reaching the same quantity at 10 steps, so after this it will end at also the same thing. So L of n equals to L of n plus 1 equals to L of n plus 2, right?
Yes, because from there it would be the same for all of them.
Right. Fine.
Yeah.
Right. So I think the next one is some programming that you can do, I think, later. The question 6, right? Okay. Now let us move to the next chapter. Next chapter is chapter 6, right? So linear equation and the greatest common divisor.
Okay. Equation and the greatest common divisor.
Right. So what is a linear equation they are saying is, so let me write down. So you have so suppose there is two integers, a and b are two whole numbers, right? Then ax plus by. So if I get this thing for all possible integer values, all possible integers x and y, right? So these are in some sense it is equal to something. This is called a linear equation or something, you can say. Okay.
Okay.
Right. So more generally, what will happen is, so the GCD, so GCD of AB, we can write it in the form of ax plus by for some integers x and y.
The GCD, right, like the Euclidean algorithm, right?
Yes. Okay. So an example what they're giving is that GCD of 42 and 30. So that is 6, right? So that we can write it as 42 times of minus 2 plus 30 times of 3. So this is a linear equation.
What is a linear equation?
Yes, linear equation is just thing. So there is only one equation in linear variables, right? So x and y, there is no quadratic, right? There is no x square y square. So they are linear, right?
Right. Yes.
Okay. Right.
So you're saying that GCD would be a linear equation as well? GCD
Yes. So this GCD equals to ax plus by. So this is a linear equation in x and y, right? So there exist
Yeah.
integers x and y, so that we can go from the get from the Euclidean algorithm, right? Right. So one result is there, or one observation. They have boxed that thing. So the smallest positive value, smallest positive value of ax plus by. So if I vary x and y through integers is equal to the GCD.
The smallest positive value
Of ax plus by.
Right, that would be the GCD. Yep. Yes, I
Right.
guess. Yeah.
Right.
But
So
what do you mean the smallest positive value of AX plus
right, ax
BY?
plus by, where x and y we are varying from varying through integers, all the integers.
Integers. Okay, integers. Got it.
Okay.
Yeah.
Okay. So the Euclidean algorithm we already know. So the next thing is, so actually here they are showing the Euclidean algorithm. So if you go down, so they are showing the Euclidean algorithm for GCD of 22 and 60, right?
16. Yeah.
Right. So then after that, in the next page, actually they are showing how to go back from the up. That we already know, right?
It's the same thing.
Yes, yes.
But okay.
Fine.
Yeah.
So I think more or less that is the thing in this chapter. Okay. So what I have is, let me check. Okay. Okay. So you can directly go to the theorem. So the theorem is on page 42.
Okay, the theorem. Okay.
Okay. Let us see the theorem. So it is called linear equation theorem. So that is saying that, so let a and b be non-zero integers, right? And g be the GCD of ab. The equation ax plus by equals to g always have a solution in integers. Right. And we know that is by Euclidean algorithm, and then every solution to the equation can be obtained by, so that the solution is actually not unique, so that is what they think. So then every solution to the equation can be obtained by, so the general solution is this. So x1, suppose this is x1, y1 is the one solution, then x1 plus k times b by g, and y1 minus k times a by g. So this is the general solution. So here k can be any integer. So
Okay.
how? Yes. So let me show you that how we are getting this thing. So x1 and y1 is a solution, right? So I have ax1 plus by1 equals to g, right? Okay. So now if I let us substitute this thing on the new solution, let us check what happens. So x1 plus k times b by g plus b of y1 minus k times of a by g, right?
So you are replacing?
Yes, I am replacing. So we have to verify that this solution works for any integer value of k, right?
X1 plus KBG. So K. Okay. K is just anything.
Right, k is any integer. Fine.
Okay.
Right. So now if I multiply just this, so I have ax1 plus k times ab by g plus by1 minus k times of ab by g, right? So now these two terms will cancel, right? Right. So what I have is ax1 plus by1. But this I already know. This is g, right? So that comes from here. So this is also a solution. So this is a general solution. I can change for any value of k integer.
Okay, so you just replace, and then you're saying that is equal to g.
Right. Yes. So that is the thing, right? We have to verify that this is also a solution to this linear equation, right? So that is what we have done. So I have proved that if I substitute this, so that is equals to g. So this is also a solution for this linear equation, and k can be any integer. So it does not depend upon k.
So that thing that is in parentheses, it's like x and y. So that's why you replace
Yes,
that
yes,
x
yes.
into the formula above. Okay, you see.
Okay.
Mm-hmm.
Right. So yes. So now we can. I think in the next page they have given that example. So 60 and 22. We know that the GCD is 2, right? And minus 4 comma 11. So what they are doing is so GCD of 60 and 22. So this is 2.
Okay.
And the linear equation is 60x plus 22y, right?
60. Wait. Okay, that will be yes, of course, yes.
Right.
60.
Right. So you can so one can check that if x equals to minus 4 and y equals to 11. So this actually you get from the Euclidean algorithm, right? So this is a solution to the equation. So 2 equals to 60 times of minus 4 plus
Okay,
22
that's
times of,
one solution.
right, that is one solution. So minus 4
Mm-hmm.
comma 11 is one solution. So the
Right.
general solution will look like, so the general solution will be minus 4 plus 11k and 11 minus 30k, right?
So the general solution would be x1,
Right.
which is in this case minus 4,
Minus 4.
plus k b over g.
Right.
So b would be 11,
No.
and
B
g
is
would be,
22, right? This is A.
oh,
This
b
is A.
is from the, okay, that would be b 22 over g, which is 2.
Right.
Mm-hmm.
And the
And
next one
then would
is
be J1, which going to be 11 minus K A 60 over 2. Okay, that
so
makes
that's why
a
it's
general
30.
solution. Right.
Okay.
Mm-hmm.
Okay. So I think more or less this one is clear, right?
Yes, the
Okay.
general
So
solution. So you just replace K by any integer, and then you have all the solutions.
right. So you can replace k by any integer, and we have all the solutions. Yes.
Okay.
Okay. So let us. We can now go to the exercises, right?
Mm-hmm.
Okay.
Mm-hmm.
So let us try the first one. So they're asked to find an integer solution to the equation. Yes. So you have to find first the GCD, right?
Yeah, we're going to find that you see.
Right.
So
So yes, you have to use the Euclidean algorithm. So tell me.
Euclidean. Okay, let's do this. That would be. I think we've done this before. Okay, so that would
Okay.
be.
Let me check once. So 1, 2, 3, 4, 5, right?
Yeah.
Um, Yes. So I think this one, right?
15. Yeah.
Right. So let us copy this one. Okay. So this is the GCD. Then what do we have? So then
So we have that 1, 2, 3, 5, 6.
right, we have to go back, right? So 15 equals to 1, 2, 3, 4, 5 minus
15.
6, 5, right?
Oh, you need to find, you want to find the x and y.
Yes. So that is the question, right? We have to
Okay.
find the x and y.
Right. So 15 would be 1, 2, 3, 5 minus 2. Okay, and then
We have to replace this 6, 1, 6, 5, right?
say 6, 7, 8, 9, 0 minus 5, 1, 2, 3, 5.
Right.
Okay.
And then
That would be 6 multiplied by 1, 2,
no,
3, 5.
not 6. 2 times 5, right? 10 and 11.
Oh, 10, 11, right. Minus 2, 6, 7, 8, 9, 0.
Right.
So one
So
solution will be 11 minus 2.
right. So one solution x comma y 11 and minus 2, right?
Yes.
Okay. What about the part B? So this also we have to do.
So we don't need to find the general.
No, for this one we don't have to find the general. So they are only asking a single solution. So I think this is enough.
Okay. Find
So
a solution. Okay.
so part B is yes. So 5, 4, 3, 2, 1. Right. So you have to find the GCD. So tell me.
Okay. That would be 5, 5, 5, 4, 3, 2, 1.
Yes.
Was going to be equal to 5 times 9876 plus 4941.
Right. And then
Then
9876 equals to
1 time right?
yes. One time. Then remainder will be
4935.
what is it? Right. 4941 will be 1 times 4935 plus 6.
6.
Yes. So how many times it will go?
822
Okay.
plus 3. 6. 2 times
Right.
3 is 0.
So this is equals to the GCD, right?
The GCD would be 3.
Right. So we have
And
to
then we
go
need
back
to go
now.
back.
So
So
3
3
equals to
with 4935 minus 822 multiplied by 6. Then
6 we have to replace, right?
6 will be 4941 minus 4935. So we should first combine that, right? And then
Yes. So 823, right?
823 minus 4941.
Right. Now we have to replace 4935. So it is 9876 and 4941, right?
Yeah, 9976 minus 941 minus 41, huh? That would be
Yes, minus.
That would be 1645.
Yes, 1645. Okay. So next, what you have to replace? 4941, right?
4941.
So
It would be
54321.
54321.
Minus 5 times of 9876.
Right.
Okay. So now if we combine, then what happens? So 1645 into 5 times 5 plus 823. Right?
Yes.
So it is 9048. Okay. So this is the thing. So the solution will be, so
Solution would be minus 1645, comma 9048.
yes. So your x is this thing, right? So this is x, and this is y, right?
Yeah.
So this is the solution, right?
Yes. To build the general form, you just need any solution, not the minimum.
Yes, yes. So they have only asked to find a single solution, right? So that is fine. So now for part 2, for example, they are saying to find describe all integer solutions. So here we will need that general equation. Okay. So let us try the first one. So 2 part A. So here the equation is 105x plus 121y equals to 1. Right. So here
Okay,
already
first
we know that, yes.
we need a solution for this.
Right. First we need a solution, then we will go for the general solution. Because they have asked for all solutions, right?
Yeah.
So yes, so they have given equals to 1. Okay, so we have to use the Euclidean algorithm. So 121 equals to
1 time 105 plus 16.
right.
Then 105 is going to be 8. No.
No, not 8. It will be
6.
cross 6, right?
6.
9.
9. 16 is equal to 9 plus 7. 9 is equal to 1 plus 2. 7 is equal to 2 times 3 plus 1. And 2 is equal to 2 times 1.
Yes, yes. Right. So the thing is, this is it. So you have to now go backward. So 1 equals to 7 minus 3 times 2. So 2 is 9 minus 7.
Minus 7.
So 4 times 7 minus 3 times 9. Now 7 you have to replace.
16 minus 9. 3 times 9. 4 minus 7 times
Right.
9.
Right.
Yeah.
So 7 times 6.
42, 46.
7 times 6 is 42. Right. Plus 4.
4, 46. 16 minus 7 times 105.
So now 16 you have to replace. 121 minus. Right. So 46 plus 7, right?
6.
Fine. So what is one solution that we got is? Okay. So we had 105 times minus 53 plus 121 times 46 equals to 1. So this is our x, this is our y. So one solution is minus 53 and 46. Yes, now we have to find all solution. So what is the general formula?
That would be x1 plus k bg.
Right, so x1 plus k times
B is going to be 121.
Right, g is 1,
Over
right?
G, which is 1, right, comma, G1 is going to be 46 minus K 105 over 1.
Right, so 121k minus 53 and 46 minus 105k. So this is our all integer solution. So k belongs to integers. Okay. So I think remaining part B and part C are similar, right? So that we can do. That is fine.
So when it says all integer, it means to express it in K, because K already represents all integers.
Yes, k we can use for any. Yes, instead of k we can put any value of integer. So that is the idea.
Okay.
Right. So part B and part C are similar. That we can skip, right? Okay. Right. So part 3 is also some computer program. I think that you can do maybe later. Okay. Okay. Let us see question 4. So, right. So the question 4 is they are saying that find integers x, y, and z. Such that. So 4 part A. X, y, z belongs to integers you have to find such that 6x plus 15y plus 20z equals to 1. Right. So
Find
now there are
integers satisfying. So why there are 3 now? So
yes. Now we have to yes. Now we have to find the 3 integers x, y, z such that this happens. Okay. So basically, what we are trying to do is we will trying to solve 2 at a time and then extend the thing. Okay.
Okay.
So the idea is okay. So let us solve for right. So 6 and 15. What is the GCD?
3.
Right. So let us try to find integers such that we have the linear equation. Suppose 6a plus 15b equals to 3. So let us find a solution. So what will be that? So can you guess? Or you have to Euclidean algorithm is very simple, right? So it is only small numbers. So
Let's see.
So
could
the
be
nearest one
a
is
minus 2.
a minus 2.
And b 1.
Right. Yes, that you can have, right? Okay. So next what you have is right. So one solution of this will be a comma b minus 2 comma 1, right? Okay. So now one observation is, so this equation I can write like this. So I can take 3 common. Since the GCD is 3, it's 2x plus 5y plus 20z, right? Equals to 1, right? So now if I find a solution so if this I can now substitute as a different variable. So I can take this as a x. So now I can reduce the equation to two variable. Right. So my new equation is 3x plus 20z equals to 1. Right. Can we find a solution?
Maybe x.
Yeah, we can put 7, right? X equals to 7, right?
7 and minus 1.
Right. So a solution to this is 7 comma minus 1, right? Okay.
Yeah.
Okay. So now we have to find the solution for the original one, right?
Sorry?
So you have to find the solution, right? Solution for the original one, right? So what
For
we
the
got
general
is
one, okay.
right. So x is 7 that we got, right? So 3. So 3 times of minus 7 plus 20 z is 3, this is 7. 20 times of minus 1, this is equals to 1, right?
Right.
Now 3 I can put it back like this, right? So 3 I can put 6a plus 15b, right? So 6a plus 15b times 7, this is 1, right? So but we have a solution for ab, that is also minus 1 and 1. So 6 times of minus 2 times 7 plus 15 times of 1 times 7 plus 20 times of minus 1, that is 1, right? So finally what we got is right.
Okay, so you are creating the
Right. So we are first reducing the 3 variable equation into 2 variables because we know how to solve 2 variables, right?
I see, okay.
So one solution to this equation will be xyz is minus 14, 7 and minus 1.
Okay, so you're saying you assume that 6a plus 15b is 3 because that is one of the solutions.
Right.
And then from there you just replace below, okay?
Fine.
So this minus 14, 7 and minus 1 is again one solution, or is the only solution?
Yes, this is the one solution, right? So this is what they're asking, right? So they're asking to give a find integers x and y that x, y and z that satisfy this equation, right?
Yeah.
So this is fine, right?
Yeah.
Okay. So what is part B? So part B, they're asking. So under what conditions ABC we have ax plus by plus cz equals to 1. This will have a solution.
What conditions?
Right.
Has only one solution or has any solution?
Yes, means at least one solution for now. On what condition it will have. Right. So yes, so this is the 3 variable case, right? So if you remember, for 2 variables, that when it is was ax plus by equals to 1. So this only has a solution when the GCD of AB was 1, right?
Okay.
Right. So similarly, can we say something here? So solution means a solution in integers. We want integer solutions.
Sorry, what was the question?
No, the question they're asking is the condition on A, B, and C such that so they have integer solutions, right? Yes.
Right.
Yes. So I know for the 2 variable case that the condition is that GCD has to be 1, right?
Okay.
Yes. So what will be that for the now this 3 variable equation x, y, and z? Then what will be the condition? That is the question.
I mean, it should be the same, right?
Yes. So it will be same, right? So the GCD between A, B, and C, they has to be 1, right? But how to prove that? Try to prove that, right? So the condition is that GCD of A, B, and C is 1. So this is the condition, right?
Okay. How would you prove that? No idea.
Yes. So the thing is, we have to prove that first we have assumed that this equation has a solution, right? And we have to prove that the GCD is 1. So it cannot be anything more. Yes. So we can prove by contradiction, right? So we will assume that suppose D is the GCD. ABC, right? Right. And suppose D is strictly greater than 1. Right?
Okay.
And this equation has a solution. So, comma D greater than 1. And ax plus by plus cz equals to 1 as a solution. Right?
Okay.
So now since G is the GCD, so D divides A, D divides B, and D divides C. Right? So from here, can we arrive at a contradiction?
So A would be a number of times D, D would be a number of times B, and so on.
Right. So right. So if D divides A, right, and D divides B, D divides C. So from the equation, ax plus by plus cz equals to 1. So can we arrive at a contradiction? So that is the idea.
Maybe because I mean, if you express it like a equal to, let's say, md,
Right. So suppose
then
a equals to d
then
times
you
suppose a1,
uh-huh,
d times b1, and c equals to d times c1. Right. Now if I put back into the equation, right.
right,
So I have a, so d a1 x, d b1 y plus d c1 z, that is equals to 1, right?
right.
So if I take d common, right, so this will imply that d divides 1, right? But that is a contradiction, right? Because I have assumed that d is greater than 1, right?
D
So
divides one. Okay, because we are talking about only integers.
right, we are talking only about integers, right? So this is a contradiction.
Mm-hmm.
So this is not possible. So the GCD has to be 1. So right. So this
Right.
implies the GCD of ABC, this is 1. So now we have to prove the converse direction also. So the converse is, we assume that so conversely, so we assume that the GCD is 1, and prove that the equation has a solution, that ax plus by plus cz equals to 1 has a solution. So this is the converse. So how to do it?
Mm-hmm.
That is the thing. So the thing is, we know that two variable we have a solution, right? So GCD of ABC equals to 1. So this will automatically imply that GCD of AB is also 1, right?
Yes.
Right.
The
So
reason
since,
I mean,
yes, tell.
I don't know that for a fact. I mean, you could have like, let's say, 15
Right.
and 7. The GCD would be 1.
Okay.
So let's say you have
Okay. Not
22.
okay. So for example, let us take yes, there you are correct. So it can be have some GCD, right? Suppose G,
Mm-hmm.
right? So then what will happen?
How? I mean, what will be the next step? Like, what are we trying to do?
Okay. So let us say, so let this is the GCD. So now I know that there is a solution ax plus by equals to G, right?
Okay.
Right. So now the thing is, since all of the three of them does not have a common factor, so GCD of G and C, this is 1, right? This I know. This I
Okay.
know, right? Because if GCD is more than this thing, then it cannot happen, right? Fine.
Okay. Yeah.
So then what we can do? So so this equals to 1. So this implies that g some w plus cz equals to 1, right? For some integers w and z, right?
So you said, okay, the GCD of G, which is AB, comma C is equal 1. Yes, that makes sense. Yeah, I get. Yeah. Okay.
Right. So this have a solution. So now I can put back this g, right? So I know from here I can put back the value of g, right?
Right.
So so what I'll have is ax plus by times w plus cz equals to 1, right?
Yeah.
So I have axw plus byw plus cz equals to 1.
Right. Yeah.
So xw, yw, and z. So this is a solution to my equation.
Okay.
So yes. So if GCD of 3 of them is 1, so then we can actually tell that this happens. So
okay. So we're saying that under the condition that GCD of ABC is equal to 1,
yes,
we have the solutions for that condition. We have the solutions that is x
right,
w comma y w z. Okay, and x w z are integers, any kind of integer.
right,
Okay.
fine.
Mm-hmm.
Okay.